So, all right, guys. So you guys can see those. So I actually printing out the exam one review question, but there was some typo that I gotta fix. Okay, so I'm gonna fix that soon, and afterwards, we're going to have the I'm gonna plan out the solution and upload it. So I do apologize for a little inconvenience, but we should be able to see what it is. Okay, and so today we're going to go to the last part of chapter three. So chapter three, let me just do that. The last part of chapter three, and it's going to be on the final summary that we finish. So we should know how to read the chart and compare different quartiles. So today we're going to continue on the chapter, the mean, the standard deviation. Okay, so the first part of it. So we need to understand the different values. So the mean, which is called the average. Okay, so this is basically one of the very important things. This is what we call the central point tendencies, or central point of values, right? Of the entire data set. So in order to compute the average, you simply just add of, right? So the competition part, you just simply add of all the data's values. So when we change the data set values, basically change the average of the data set points. So we add up the data value and divide it by n. Okay. So I can give you the form, but I feel like the form is sort of confusing. So the sample means denoted by x bar, right? Denoted by x bar. And that can be computed by uh, equal to so we just add up all the data set values, right? You take you're gonna take x1 bars, x2, something like that. Plus x2 plus x3. Xn. Okay. This was x1, x2, x3, and xn. And then we divide it by n, which is the number of data set point. Okay. All right. So let's take let's take a look at a few examples. So compute the average of the following. So all we have to do is just simply, so let's say we have a bunch of data set point 8. So we have like 3, 5, 10, 12, and 15, right? So all we have to do is just look for the X bar, and then you just simply take 3 plus 5 plus 10 plus 12 plus 15. So the number of data that we have was n equal to 5. So we have 5 data set point, which is what n equal to 5 in this case. So that being said, we're going to divide it by 5. So when you do it in a calculator, of course, we use the decimal calculator to compute it. So the decimal calculator just goes to decimals, scientific calculator, and then we just add them up divided by 5. So we have the answer will be 9. Are we good? So there's nothing really special with this one. But when we just look for the average, we just simply add them up and divide it by the number of data set points. So let's look at the part B question. You can try a different example for that. So let's say we're going to take the data, let's say like 1, 2, and then 10 and 15, 12 and 15. Okay, so we do basically do the same thing for that. We're going to compute the X bar. So we simply add them up, right? So we take 1 plus, oops, 1 plus 2 plus 12 plus 14 plus 15. And then we divide it by 5 again. So we just add them up again. So we take like 1 plus 2 plus 12 plus 14 plus 15 divided by 5. So we have the answer is 8.8. And we get, if we have 6 data set, we just divide it by 6. If we have 7 data set, just divide it by 7, so on and so forth. So now, given by those two types of data, somehow it's really hard to see what it is. So we look at the range. So in order to compare those data set point, we compare when comparing those data set. So we literally check that the first data had the smaller range, like first data point has have a smaller range, right? So the range was 15 minus 312. And but the data is a little more consistent than the adder. So the reason why I call this consistent, so this is what we going to look at. So you can literally check that the jump on the first data set point that we have. So we're going to start with the 3, right? and then it's jumped to 5, and then afterward it's jumped to 10, it's jumped to 12 and 15. So the average that we have was 9. So the mean that we have is 9 right here. So this is 9. Oops. So on the other hand, we look at the second data set type. So you can literally check that it's the data started from 1, right? And then 2, and then 12, and then 14 and 15. So the average that we have was 8.8, should be around here. So uh, if you're using a phone calculator, you have to put an airplane mode. You have to sit in the front when it comes to the exam. Yeah. So the phone calculator would not be allowed, most likely, unless there's no images that we have um, on the test, whatever it is, on the exam review question. So, I mean, you're more than welcome to use it, but I strongly recommend you have the physical calculator. But if you're using a phone calculator, you have to put it in airplane mode if you're using a decimal calculator. So, yeah, so when is the exams? The exam's going to be on next Tuesday. I'm going to post the exam review and the solution very soon for these lectures. So let me just start with the standing deviation. This is what we have to focus on. Before that, I just want to emphasize the exams. One is going to be a next. It's going to be a next Tuesday. Okay. Start at 10 a.m. in the morning until 11:15 a.m. So it's going to cover chapter 1, 2, and 3. Okay. And of course, that you're allowed to bring a page of notes, right? So please bring a page of notes. Okay. Let's say a page of notes it's a very important thing. You can write whatever you want to, which is perfectly fine.
When you say a page of notes, you mean just the front, right?
Double sided. Just make it double sided.
Okay, thank you.
You're welcome. Like front and back page.
Can it
But
be
just,
typed as well?
I'm sorry.
Can it be typed?
You can type it, but I prefer people write down so that your friend sitting next to you will not be able to see what it is. I'm just kidding, but you can type. But what I'm saying it's better that you prepare your own notes, right? Especially when it comes to the Thursday. I'm gonna have the lecture notes uploaded. So which focus on the exam review questions that I'm gonna upload and post solution as well. And I hope that you guys understand that the exams questions basically combine, it's a combination of the lecture notes, the chapter summary, and the homework assignments. So the homework assignments on Lumen is very, very important. So make sure we can practice, we do all of them. If you study the test chapter, if you did the chapter test perfectly, you should get around like 40% of the grade. Okay, so make sure that we plan out ahead of it, ahead of the schedule, and also that we should bring like a physical calculator. So the physical calculator, so you'll be using a decimal and phones. Make sure that you have to check the connection, so it's check with no connection. Okay. And also there's no notes, right? So I have a student just like, you know, just copy all the notes. I mean, we're allowed to bring notes. I don't think there any situation that you should, take picture of the notes and so on. So unless you don't need enough, you need more uh, pages. But I strongly suggest this, just check no connections, no notes on the phone. And also that you should bring a pen and pencil. I have seen people just did not pass the exam without pen and pencil. So it's a very, very important thing. I prefer to write with pencil sometimes, but there's nothing wrong with writing down the exam, using pen. Um, so if you sort of like, I want you to erase some word with my pen, I'm sorry, with my pencil, you can more than welcome to do so. All right, guys. So now we're gonna move to the next part, just making sure that we understand this. This is what we call the exams. So the exam one review should be posted. Will be posted uh, on Blackboard. Okay, and solution. So I haven't really made the file yet, but um, it should be here. Let me just. I'm definitely going to show you what it is. So let me just complete this first. So exam one review is posted. And solution we post on Blackboard. Make sure that we check them. So now we're going to go to the next part we call a standard deviation. So if you ask what it means by the standard deviation is simply it's just represent, right? It just measure the spread of the data set, or sometimes that we call consistency of the data set point. So the reason why I use the word spread and consistency, so it's meaning that it just measure how fast and it's gonna jump up and jump down in terms of the data set values, right? So when it comes to the final summary, you don't have this characteristic. So we just simply measure the data like from small to big, and then afterward you look for Q1, Q2, Q3. So that's represent the quartiles, 25, 50, 75 percentile. We just care much more about the position of each data set point. But when it comes to the standard deviation, it's different because we're going to measure the spread and the consistency of a data set point. So why is so the data represent more consistent. Well, it's if the changes were not that big. So let's say we look at the first two example, right? So the first two example, we literally have the same data set points, correct? So we have each data, they have 5 data sets, right? However, we can look at those. The first one, so the first one is more consistent compared to the second data set. So I would say the first one is more consistent because you can see the jump, you can measure the jump. It's not really as fast as the second data set point. So we look at that. So it's just jump from 3 to 5, from 5 to 10, 10 to 12, and 12 to 15. But now we can look at the second data. It's jumping from 1 to 2, which is only one jump different. And then all of a sudden it jump from 2 to 12. This is a big jump, right? This is a really, really big jump. So, and then jump from 12 to 14, 14 to 15 is not that big, but the jump from 2 to 12 actually make a big gap, right? It's up a data. It just make the data more, less consistent, in other words, right? More volatile. And so this is the word that we're looking for. So in other words, the second data, so this data set should give us the bigger standard deviation. Okay, so this data should give us the bigger standard deviation. So in order to compute the standard deviation, so we just basically compute it by the average deviation. Okay, which is the average difference between. I would use the word difference because it's not about being different. It's like we have to take the square or something like that. Compute average deviation, which is the average difference between each data to the mean to the average point to explore. All right, so in order to set up this, that we need to have like a certain types. We're going to to move to a different way of computing the standard deviation. Actually, a few way of doing it. So let's say we compare the first data set that we have right here. So let's look at the first data. Okay, so I call them a sample data set. So we're gonna do that with a sample standard deviation. So for each data set, we're going to make like a chart things. Okay, so I'm gonna make like this. So you have like 1, 2, 3, and 4 column. So the column number 3 should have more space. So when we do the math, so this one you're gonna put them down as the data, right? So this is X bar. And this is X bar. And this is the deviation. Okay. And this is a square deviation. I would call it X square deviation square, D square. Okay, so the first thing you have to do, you're going to put down all the data set points right here. Let's say we're going to put that down to 11, 3, 5, 10, 12, and 15. Okay. Are we good with those? So the first thing we have to do is just put all the data set down. The second thing, we're going to put the X bar. export that we have was which computed. We got the answer was for the first exam we got the answer was 9. So put them down as 9. Are we good? So it's simply just like put the first one and put the data set. The second one just put down the deviation. I'm sorry, the export that we computed. Now after we're gonna subtract them, take the F3 minus 9. So we just compute a difference between each data set point to the average. So we got this one -6. Okay. Are we good? So we do the same thing for that. We take 5 minus 9. And we get -4. The now is just the average. The averages that we computed, x bar equal to 9, we just add them up, divided by 5, you get 9. So compute it in the first part. Okay. So we do the same thing for that. We take 10 minus 9 equal to 1. And we do the same thing for that. We take 12. Then we minus 9. And we have that equal to 3. Are we good? And then 15 minus 9 equals 6. Any question? Any concern? And after we're going to square each of them, right? You're going to take -6 square. So it's going to square them. So we get the answers right here equal to 36. Are we good? And then, so the reason why we have this square, because when you add them up, so the total deviation have to be equal to 0. So we can't add them up like that. So when you add up these value, every single case, you're gonna get total deviation equal to 0 for sure, 100%. So we can't. So we trying to measure the difference, the average difference. So we can't really do it that way. So which is why we have to square them. Yeah, with this type of problem, we'll also be on the test. Definitely going to be on the third exams for that. So we cannot add them up. So we have to square each of those, and then we do the same thing. So in order to do this better, so I would strongly suggest people just ignore the sign, ignore the negative side, just square each of these values. So we're gonna get 4 squared equal to 16. And then 1 squared equal to 1. Are we good? And 3 squared equal to 9. And 6 squared equal to 36. Why the total deviation is equal to 0? So the reason behind that, because it's simply neutralize all the data set values. So meaning that, let's say, the difference between 3 to 9 was 6, -6, and 5 to 9 was -4, and then 10 to 9 was 1, 9 to 12 was 3, and 15 to 9 was 6. Look at that. I says the central is average is simply the central tendency just to point the value of the entire data set. So meaning that it's always mix the data. It's always basically the central point. It's going to average out every single data set value. So when it's going to make the total difference of each data set absolutely equal to 0. The same thing for that. When you look at those, when you take like a difference between 1 and 8.8, 2 to 8.8, and then 12 to 8.8, 14 to 8.8, it's going to make the data set equal to 0 for sure. Okay. So you can literally try them. So you can try it for the second time of data. It's when you add up the total deviations, always be 0. So afterwards, we're going to add them up. All of these data set, we're going to add them up, correct? So you're going to take a total for this. So we're going to take a total, we get 36. It's 98, correct? And we get the total was 98.
Yes, it's 98.
Okay. And afterwards, we simply divide it by n-1. So no, most of the data is sample, right? You have to take note for that. Most of the data set of the collected data is called sample, right? So when it comes to the sample standard deviations, so we have to divide it by n-1 when you take a total for that. After we take a total for that, so when you gotta divide it, we have to divide it n-1 instead of n. That is a long story. So the reason behind that, because the sample standard deviation is trying to duplicate the population characteristics. So meaning they trying to make it simple for that. But since the sample data is a very, very small data set point, it can be 20 data. If we come to like a million data set of the population, it can be only like a few data set point. So in order to make that a little, similar to what we have for the population, because we only collect like a very, very few data sets, right? So we have to divide it by n-1 for a sample standard deviation. Standard deviation. Okay. So we have 5 data sets. So n-1 is 4. Okay, n-1 is 4. So we have to divide it by 4. Instead of 5. So 94 over 8. 98 over 4. I'm so sorry. So I get 24.5. Are we good? And afterwards, the sample standard deviation just represented by S, the small s. So this is the syntax for a sample standard deviation. and we just take the square for that. The square of 24.5.
Professor,
Yeah.
I'm confused. How we get the 4 from?
So we have 5 datas, correct?
Uh-huh.
So we have 5 data. We take away 1. So 5 minus 1 is 4.
Uh-huh.
So we just divide it by 4 instead of 5.
Okay.
When we compute it by the average, we divide it by 5, correct? There's nothing wrong with that. But when we compute the sample standard deviations, then we have to divide it by 4. So that's the difference. Okay, are we good? And afterward, we're gonna take the reason why we have to do the square root, because again, we have to square them for each data set point, and then we add them up, we divide it by 4. But we're looking for the spread, how much data is gonna spread out. So meaning that we're going to take the square root for this. So the square root of 24.5 equal to 4.94. Oh, 4.95, you want to round up to 4.95. Are we good? Any question? So we can also do it that way as well. So we can use a calculator. We take the square root of the sum. So we're going to compute each data set different. So the 3 minus 9, right? So we take the divisions here. So 3 minus 9. And then do the square and plus 5, 10, 12, 15. And then we just divide it by 5 minus 1 is 4. So we can literally get the answer, which is 4.9. Are we good? Is that good, people?
Yes.
Yeah. So this basically tells us that this is the average difference. So this represents the average difference. The average difference. Different. Between each data set to the average, to the point, to the average. So what is the average for that was 9, correct? So yes. So when we complete to the last step, most likely when we compute the average, it still be unchanged. That we have to divide it by 5. But when we try to get to the total, the last step after we add up the total, and then when we divide it, we have to divide it by n minus 1. So this is going to be make a difference. So we divide it by n minus 1 instead of 4. I'm sorry, instead of 5. So we divide it by 4. All right, guys. So we're gonna do one more practice, and we're going to look at those data sets, which is we have a second type as well, right? And then we also have X bar was computed by 8.8 that we did it earlier. right? 8.8 was X bar. And then we're simply going to make a chart as well.
And that's okay, everybody. I don't expect anybody to be perfect each and every time, and definitely not my kids. Sometimes they just don't want to get a haircut. I've learned that if you give them out, most of the time they're going to take it. So sometimes, like, leave.
Okay, so and then we do the same thing for that. So the second column. This is you can't just compute it by doing all the math on the calculator. So which is perfectly fine. So this one we call the data. And this one we call X bar. And this one we call deviation, D, right? And this one is D squared. All right, so the data set that we have was, so the data set that we have was 1, 2, 12, 14, and 15. Okay. Are we good? And then the mean was 8.8, 8.8, 8.8. Okay. And after we're going to take each data minus the mean. So we're going to get this one. So 1 minus 8. And that's going to give us a negative 7.8. Okay. So we do this, we do it exactly the same thing. We take 2 minus 8.8. And we get this one equal to negative 6.8. Okay, so we do the same thing for all of this value. So we get this one is 3.2, correct? And this one is 5.2. And this one was 6.2. And then you're going to square each of those. So 7.8 squared is 60.84. And 6.8 squared with 46.24. And then 3.2 squared, 10.24. And afterward, 5.2 squared. And then we got 27.04. And 6.2 squared. We're going to get this one equal to 38.84. Okay, are we good? Is that good, people? And we simply add them up, take a total again. So again, that the total should be computed. Again, on a calculator, we're going to take 60.84 plus 46.24 plus 10.24 plus 27.04 plus 38.44. So we have the total is 182.8. Are we good? Are we good with that, people? So afterward, we just divide it by n minus 1. So now we have 5 data sets, correct? So we take minus 1. So n minus 1 is 5 minus 1 is 4. So we need 4 data. Just divide it by 4. So we take 182.8 divided by 4. And we have the answer is 45.7. Are we good? And afterwards, we're going to compute a sample standard deviation. So S will be the square root of 45.7. And that's going to be your final answers. We have to do it in a calculator, of course. So we have the answer 6.76. Any question, any concern? So, like I said, like the second data set point generate a bigger standard deviation compared to the first one, right? Because 6.76 is greater than 4.94. So the first data set is more consistent. So the first data point are less consistent. All right, guys. I feel like that's pretty much. You have any question? You have any concern? Okay, so if there's no questions, then we move up to um, the homework, some homework assignments. So let me go to Lumen. So we're definitely gonna do some practice for the mod. Make sure that it's the second test, the chapter test is due on Monday, February 19. Make sure we do all of them. So we can literally find the mean, the median, so the means that we have, and then the median, so on and so forth. Okay. And then we should be able to do one question. I feel like that's very important. We should do what it is. So this is what we're trying to look for the data set from the quiz, right? So if the question gives like the number of data with frequency, then we might have to take the average point, the middle point, or we just simply, we multiply by the corresponding frequency. So this is what we call the weight average. So the weight average is just like, so each data set point had different weight. So we have to be really careful when you compute it. So let's say in order to compute the X bar, so what we have to do, we're going to take like, so we're going to multiply with each corresponding frequency. You're going to take test score times 4. So we're going to take 3. So test score with 3, and it has like 4 frequency. So this is, so each 3 point going to have like repeated 4 times. So like we have 4 people who score 3 points on a test on the quiz. So we're gonna take 3 times 4 plus 4 times 2 plus 5 times 2 plus 6 times 4 plus 7 times 1. So 7 times 1, we have one person who scored like 7 points on the test. And then 8 times 2 plus 9 times 1 plus 10 times 5. Are we good? So the total frequency that we should compute it by adding all of this together on this column, so we can find a number of students who took the quiz. So we have in the scenario 12, and then 13, 15, 21. We have 21 people, correct? So we have to divide it by the total 21 student who took the test score, who took the test, and then we have to divide it by 21. So we take 3 times 4 plus 4 times 2 plus 5 times 2 plus 6 times 4 plus 8, 7 times 1, 8 times 2, 9 times 1 is 10 times 5. So we have 136, and then we divide it by 21. So we have the answer to 6.47. Are we good? Any question? How do we get 21s? Because we have 4 people who score 3 points on a test, 2 people who score 4, 2 who score 5, 4 who score 6. So we just add them up. We add them up on the frequency column. We're going to get a total number of people. Any question? Any concern? No. Okay. So how can we find a median? So the median is like the median is simply the middle data set point, right? So the median is a middle data set point. Is a middle data set point. Correct? So we have 21 people. So it doesn't really matter about the score. What it does is where to arrange it. And then so the median should be, so the student uh had the score has a score absolutely, the student basically is in 11 position, right? So 21 student have to be 11 positions every 10. So we're going to look at those data. So we're going to have 8. So this one is like 8, something like that, right? So we're going to look at the first 4, and then we're going to have like 12 students. Correct? Right? So we have like 12 students that have the score between 3 to 6. So in other words, the person who has the score equal to 6 uh, uh, will be so we have to locate it in the 11 positions, correct? So this one is going to be
Recording in progress.
how we get. So in this case, the median is equal to 6. Are we good? Any question?
No.
All right, guys. So let me just find out what the answer is. Of course, this has to be the test score 6.6 or something like that. There's nothing really different. And which of the following does not review the variation of the data? Anyone knows? Which of the following does not review the variation of the data, people? Sorry? The range actually reviewed the spread, correct? The medians? What do you think? The final summary also reviewed the variation spread of the data set point. Of course, you can literally check if the data was school left, school right, whether it's going to have a bigger range, a smaller range. The medians, correct? The medians does not review this the spread of data, the medians. Okay. It's just a middle. It's just like the middle point of the data set. It doesn't really tell anything. Are we good?
The median?
Yeah, that's the median. The median doesn't really say anything. All right, guys. So I'm going to upload the third exam review. Again, there are some typo that I need to, I need to fix, and then I'm gonna put the answer key as well, just making sure that we are able to do it. All of these questions. And that's pretty much the thing on third exams. I want to give you guys the topics, the number of topics next on Thursday, and after we're gonna have the third exam on Tuesday. Okay. All right, guys. So I will see you guys. So since today's a very snow day, I'm gonna mark all of you present. Okay. So do not worry about this. I know there's only 33 people, but how many questions would be on the test? So I haven't decided yet, but I'll let you know on Thursday the number of questions. It should be a combined, multiple choice questions as well as the word short answers questions and all of that. Okay. And so again, the multiple choice question is sort of tricky. I know it's nobody wants it. It's really hard to score a good grade in this class, I believe, because when you get it wrong, you don't get points for that. But I would definitely gonna try and just take some questions on the Lumen and then just put it on the test. Okay. Yes, all of these notes will be posted on Blackboard. I understand. The quiz on Lumen, there's no quiz. Do most of the homework assignments would do at the end of semester, but I really encourage you to do it. So most of the multiple choice questions will be coming from these two things. So make sure that we know what it is. If you don't have the answer, just simply send me an email for that. So I will definitely gonna help you out with some of the questions. So let's say that example is going to be a survey, for instance. So we should know what it is. So we should know how to identify the populations, right? And then the population should contain the total number of marble, whatever it is, right? And then so you should know what it is for the population. Sometimes it's double blind, single blind is I don't really go over that a lot, so I might not put them on a test. But some of the population sample, what it means by sample statistics, population parameter, and so that means a lot. So I'm gonna upload that on the exam one review. Okay. All right, guys. So I really appreciate it for the snow day that you came in here, and then once we see each other again in person, I will let you know precisely what will be on the exam. All right. So take care. Have a wonderful day. Bye.
Bye.
Bye, have a good day.
Bye, thank you. Bye, have a good one.
Cheers.